Hi, my name is Ulla Petti. I am presenting our paper on the ethical considerations in the early detection of Alzheimer's disease using speech and AI. This is a joint work with Rune and Nyrup, Skopek and Korhonen. I will start with some background information and explaining our motivation for writing this paper. Research in Alzheimer's disease detection is increasingly relevant due to aging population. While it can be challenging to diagnose, it's been found that changes in language could appear years or even decades before the diagnosis. This means that speech analysis has a great potential to help develop non-invasive, fast, cheap, and accessible screening tools. While it's a promising area of research, many ethical considerations arise. The ethics of early Alzheimer's and dementia detection have been addressed in the earlier literature, but introducing AI and natural language processing and using speech data raise novel questions that haven't received sufficient attention yet. In this paper, our aim was to address this gap, outline and discuss the concerns, and provide recommendations for developing ethical guidelines and best practices. We grouped the ethical concerns into 5 broad categories: autonomy, privacy and data protection, welfare, transparency, and fairness. I will introduce some of the points from each section that we discussed in our paper. The autonomy-related considerations that we discuss are related to informed consent, the personalization and disclosure of research outcomes. We stress the importance of being clear about the risks and benefits involved when obtaining informed consent. Depending on cognitive decline and the disease stage, it might be needed to use simple language and visual aids. As language is often connected to personhood, there is a risk of depersonalizing those with language impairment and portray them as incapable of meaningful decision-making. We highlight the importance of treating the disease that contributes to communication difficulties as separate from the person. When looking at disclosure, it's important to respect the person's right to know and not to know the research outcome, and be clear about the procedure before the study. In AI-aided detection, it's also important to explain that the model can be wrong, as this may impact the subject's decision on whether or not they wish to know the outcome. While collecting spontaneous speech data is increasingly feasible, several concerns arise. Spontaneous speech data can carry personal content, and voice acts as an identifier. While this is true in any domain using speech data, working with people with potential cognitive decline makes it especially relevant. Here we need to consider how well the speaker understands the personal content being shared, how it will be used, and how to protect them. Similarly, linking identifiable voice data to personal health information, such as the risk of developing Alzheimer's disease, introduces additional risks. Several suggestions have been proposed to reduce such risks, for example, reducing speech intelligibility, using automatic feature extraction, or giving the participants control over the recording device. One of the welfare concerns is the distress the research may cause. Going through cognitive testing can be stressful. It's important to choose the data collection methods that cause the least discomfort to the participant. Similarly, being informed about the signs of progressive neurological condition that doesn't have a cure is distressing and can lead to the development of negative self-image or even suicide. Research reliability is another aspect that may contribute to welfare-related concerns. Here we have to consider 2 things: the adequacy of the language data and the adequacy of the models. Language tests may struggle to capture the challenges that persons with Alzheimer's face in everyday conversations and be insensitive to communication-related cultural differences. Model accuracy concerns are largely related to small sample size and overfitting and incomparability across studies. We also discussed the risk of discrimination. Early signs of Alzheimer's disease can have an impact on the person's job opportunities, insurance, legal status, and access to healthcare. It's especially relevant to acknowledge the risk of unethical and dual use when the signs of disease are extracted from everyday speech, which is very easy to collect. It's essential that clinical decision-making is transparent and interpretable. In the domain of detecting early signs of Alzheimer's disease from speech using AI, transparency issues can arise on two levels. First, the extracted language features can be difficult to interpret. It's expected that as more speech data becomes available and more AI systems are used, the domain expert features will be replaced by the features that perform better. This is likely to reduce the interpretability of the language features. Second, it's important to consider the transparency of the decisions and whether we understand which features contribute to a certain decision being made. These two issues are connected. Understanding the extracted features would contribute to understanding why a certain decision about the participant's health has been made by the AI system. Several techniques have been proposed to boost interpretability. It's important to think who the explanations are meant for. Interpretability for developers helps us develop better AI as we can understand the predictions and address errors. Interpretability for users, such as doctors using AI to support diagnosis, allows them to understand why the model made a prediction, whether or not to trust it, and explain the treatment recommendations to the patients. We stress the importance of including clinician input in developing transparent models. While many studies in this domain state that the development of automatic speech-based early detection tools would make Alzheimer's disease screening more accessible, promote the quality, and improve the quality of life of the elderly, it's important to ask who will benefit from such research and whose quality of life will be improved. For example, the lack of available treatment and the advanced age of the research subjects makes them unlikely to directly benefit from the research themselves. But who will benefit from such research in the future? The design of current studies has a great impact on the future outcome. However, current datasets are often unbalanced. A lot of the models are trained on weird population and based on English language. As the models are only applicable to the population they've been trained on, it leads to disproportionate distribution of benefits, meaning that the research will largely benefit the rich Western countries. There are several suggestions to boost the fair distribution of research benefits, such as constructing balanced datasets, including various languages and minority populations, and using bias assessment toolkits and dataset descriptions. In summary, we provided an overview of the ethical considerations in the early detection of Alzheimer's disease using speech and AI, and developed a list of 65 recommendations to aid the development of guidelines and best practices. The beginning of it is shown here, but see our paper for the full list. The key takeaways are to make decisions with the best interests of the participants in mind and be clear about the communication. Consider potential consequences of developing new technologies and be aware of the risk of dual use and discrimination harm. Focus on the explainability of the models and include clinician input in the process. Include diverse populations and ensure fair distribution of research benefits. Thank you.